Hello, everyone. So, you have had 2 days of practice with me about um, looking at distributive property, but then we started to look at factoring. So, we looked at GCF, and then we also started to look at a little bit more. Okay, we're going to focus on GCF so we have a really firm understanding of that moving into next in person class. So, GCF stands for greatest common factor. And the thing I want you, the two words, actually all three. I can't pick just one, two. I have to pick all three. Greatest means we're looking for the biggest number that we can. Common, it has to be a multiple of each term. And factor also plays into the multiple piece. Okay. So what we're trying to do is we're taking the area in our model and we're looking for the dimensions. So what you remember is we started with problems like 3 times x plus 2, right? And when we looked at a problem like that, what this gave us was our dimensions. This is our length and this is our width. So we had 3 and then we had x and 2. And then to find what this equaled, or the area inside, we did 3 times x, which would be 3x, and 3 times 2, which would be 6. And so this was the dimensions. And then what we got from that by distributing was the area. Okay, so this is distributive property or distributive work. But GCF is factoring, okay? So when we go from dimensions to area, it's distributive property. Now you're going to be given the area and you've got to go to the dimensions. So what did we do? Well, what we did was we looked at a problem like, let's see, 5x squared minus 30x. So what we're given now is the area, and what the answer is the dimensions. So our answer is going to look like something times something. Okay, and I could put that in parentheses. So a couple of different ways we can do this. I'm going to represent it first by the box method. So this is one area, 5x squared, and this is another area, negative 30x. My job is to find the length and the width. Okay, so what I want to do is I want to think about what's in common. Greatest common factor, biggest number that's a multiple of each. And variables work with that too. Well, some of us can look at this and see it. Some problems we can look at and see. But what happens when you can't just look at it and see it? Well, you have to have a method. So what I'm going to do is I'm going to just jot this down, and this is what people do in their heads when they're doing it in their heads. But you're going to think about, what are the multiples of 5? Well, we have 1 and 5, 1 times 5. X squared simplifies to x times x. And then what are the multiples of negative 30 and x? Well, I have a negative 1. If I break it down all the way, I have, let's see, things that multiply to 30, 3 and 10, right? So 3 is a prime number, but 10 can be broken down into 5 and 2. And then we have an x. So now I look at this, remember my thief example, clouds, blobs, bubbles, whatever. I look at this and I say, okay, what can I take out of both of these? Well, something I notice I can take out is a 5. I notice this is a 1 and a negative 1. I could take out a 1, but that's not going to do anything for me. But I could take out an x from both of these. and that goes right here. That's my greatest common factor. That's the thing I can take out of both of these as the biggest. And then up here is what's left over, right? If I take it out, what have I got left? Well, I've got this left over here, and I've got this left over here. 1 times x is the same as saying x. -1 times 3 times 2. -1 times 3 is -3 times 2 is 6. -6. So I've got -6 and I have no variables. Okay, so what I did was I went for my area, which was given, and I found my dimensions. So I'm going to fill in my answer. My answer is 5x times x minus 6. Okay. If you need to pause the video, take a moment, write it down, then rewatch that. That's good learning. It's one of the benefits of videos. Feel free to do that. I'm going to look at one more, okay? I want to look at some of the weird-ish ones. So if we look at one more problem, I'm going to give one that the area looks kind of challenging, okay? So if I look at, let's see, 36x squared y to the third plus 4x to the third y to the third minus 12xy. So that area is longer, isn't it? I'm still trying to find something times something, okay? So I'm going to write this as an area, and I'm going to need a little bit of room, right? Because I've got 3 terms, which means 3 boxes. 36x squared y cubed, 4x cubed y cubed, and -12xy. So now if I write kind of the blobs, 36 is 6 and 6, right? 6 times 6. But I can break that down into 3 and 2, 3 and 2. So I want my prime numbers in there. So 3 times 2 times 3 times 2. And then I've got x squared and y. Okay, there's one blob. Here's my next one. 4 breaks down into 2 and 2, 3 x's and 3 y's. And my last one is -12. Well, I kind of want to think about that. -12 breaks down, well, if we think of 12, that's 6 and 2. And so that's 3 and 2 and 2. That's actually like stuff we did with the radicals, right? So 3 times 2 times 2. And we can't forget the -1, right? And then we have an x and a y. Okay, I'm an equal opportunity thief. I'm only taking the same thing from everyone. Okay, so I need my dimensions. We'll get there. But, okay, I don't have a 3 in each of those, so that's sticking around. I do have a 2 in each of them. 2, 2, 2. And I've got another 2, 2, 2, 2. And then, and by the way, this is a representative of what you took from each, not the total that you took. I notice if I also shortcuts, look for the smallest blob, and x is the smallest, so I can take 1 x from each of these. And I've got at least 1 y in each of them. And so that simplifies to 4xy. That's going to be my greatest common factor. That's the thing I can take, the most I can take from each of them. So 4xy. And what's left over? 3 times 3 is 9. And then we have 1x and 2 y's, y squared. Here we have no numbers, but we have x squared and y squared. And here we have a -3 and no variables. So my answer, the dimensions, is equal to 4xy times 9xy squared plus, I didn't give myself enough room, x squared y squared, pretend that's not there, minus 3. Now you look at this and you say, is there anything else I can take out? And the answer is no. So that means our problem's done. Now, some of you are looking at this like, God, that's a lot of work. That looks so disorganized. Oh my gosh. And it might feel that way. But this is a way of organizing your thoughts. Ultimately, we want to get to a point where we understand this so well that some of it becomes automated. So what I mean by that is maybe the next step is not drawing the blobs. Maybe the step beyond that is not drawing the area. But we do this as long as we need to. And maybe you don't get to those steps this year. That's totally fine.